Sir, group for message to like only rejoin our class cut it. Sorry, guys, had some technical issue. Yeah. So in yesterday's class, we were discussing till the total internal reflection, right? So I hope you remember this concept. Now, we will do some problems based on this concept. Then we will go to the next part. Okay. Let's try this. So there is a ray of light of frequency 5 into 10 power 14 hertz, which is passed through a liquid. What is the wavelength of the light measured inside the liquid? Sorry, the wavelength of the light measured inside the liquid is found to be 450 into 10 power minus 9 meter. Calculate the refractive index of the liquid. How to solve this? So there is a ray of light whose frequency is how much?
5 into 10 power 14.
5 into 10 power 14 hertz, and the wavelength is 450 into 10 power minus 9 meter. Now we need to calculate the refractive index of the liquid. How do we do that?
Lambda into F.
So mu is equal to C divided by V. Correct? So mu is equal to C divided by V. C is 3 into 10 power 8. V is nothing but lambda into F. But what is lambda? 450 into 10 power minus 9 into F is 5 into 10 power 14. Okay. Second, the calculation part you do it, the answer is 1.33. Actually, it should be water. Okay. Next, there is a light of wavelength 6000 angstrom in air, which enters a medium with a refractive index of 1.5. What will be the wavelength of light in that medium? So how to solve this again? So what is the relation between refractive index and the wavelengths? Mu is equal to
Lambda.
lambda 1 divided by lambda 2. So mu is how much? 1.5 is equal to, what is lambda 1? 6000 divided by lambda 2. So lambda 2 is equal to 2 into 6000, the whole divided by 3, which will give us 4000 angstrom. Three. The refractive index of glass is 1.5 and that of water is 1.3. If the speed of light in water is 2.25 into 10 power 8 meters per second, what is the speed of the light in the glass? Can you guys do it fast and tell me?
Yes, sir.
Please do it. Check if the answer given there is matching. So how to do? What are the
mu1 by
formulas?
mu2 equal to v2 by v1.
mu1 by mu2 is equal to,
v2 by v1.
okay, we put it like that. This mu1, this mu2. mu1 by mu2 is equal to v2 by v1. v2 is what we need to find. v1 is 2.25 to 10 power 8. So that implies 1.5 divided by 1.3 into
2.25 equal to 2.25.
speed of light in water.
So the
No,
answer
no.
came, sir.
Actually, answer will work. Yeah. So mu1 is 1.5 divided by 1.3 is equal to 2.25 into 10 power 8 divided by v1. Correct? So v1 will
Yes,
come out
sir.
as, this value will come actually. So v1 will be equal to 2.25 into 10 power 8 divided by 1.5 into 1.3. 1.5. So 1.5 into 1.3 is 1.95 into 10 power 8. So speed will decrease. Okay. So let's do one more problem. Fourth one. So there is a ray of light that passes through a plane boundary separating two media whose refractive indices are mu1 is equal to 3 by 2 and mu2 is equal to 4 by 3. If the ray travels from medium 1 to medium 2 at an angle of incidence 30 degrees, what is the angle of refraction? Can you guys do it fast? Tell me in terms of sine inverse. I don't want it in terms of angle. I want it in terms of sine inverse.
So I'm getting sine R is sine inverse of 9 by 16. So
Sine inverse of,
9 by 16.
okay, let us try and see. So there is a boundary. Refractive index here, the first medium is how much? 3 by 2. Refractive index in the second medium is 4 by 3. If the ray of light travels from medium 1 to medium 2, okay, and here it is incident at an angle 30 degrees. Let's say this is R. How did you apply Snell's law? 3 by
Sin I
2,
into mu 1 equal to
yeah. So mu 1 into sine 30 is equal to 4 by 3 into sine R. So 3 by 4 into 3 by 4 is equal to sine R. Are you getting R is equal to sine inverse of 9 by 12? Sorry,
9 by
9 by
16.
16. Yeah. Are you getting this?
Yes, sir.
Okay. Now they ask the second part of the question that they're asking is the ray travels from medium 2 to medium 1 at the same angle of incidence. What is the angle of refraction?
Sin inverse of 4 by 9, sir.
Working? So it will be 30 degrees. 4 by 3 into sine 30 degrees is equal to 3 by 2 into sine R. So sine R will be equal to 8 divided by 9 into sine 30 is half. Sine inverse of 4 by 9. Okay, that's right. Okay. Fifth one. There is a rectangular glass slab that rests in the bottom of a drop of water. There is a ray of light incident on the water surface at an angle of 50 degrees that passes through water into glass. Calculate the angle of refraction in glass given that the refractive index of water is 4 by 3 and that of glass is 3 by 2. Listen to this carefully. So listen to this carefully. Before we solve that problem, I want to explain you a concept. Please write it down. Refraction of light through a rectangular glass slab. Okay. Refraction of light through a rectangular glass slab is the concept. If I drop a perpendicular like this, if I take this as the angle of incidence, okay, let me call the refractive index here is, let us take this as air medium and let us take this as glass medium. Refractive index of air medium is 1, refractive index of glass medium, I will call it as mu for the time being. Okay, it is 4 by 3, but I'll call it as, sorry, it is 1.5, but I'll call it as mu. So the ray was supposed to travel in this path, correct? Now what will happen? You look at the refractive indices and tell me how is the ray traveling?
It will move towards the normal, sir.
Why? Because it is moving
Because
from
glass is more denser than air.
perfect. So it is moving from rarer to denser medium. So it bends towards the normal. So when it is bending towards the normal, it is hitting the surface at this point. Okay. Now, the refracted ray inside the glass prism will act as an incident ray for the second boundary. So if I take this point as A, this point will be B. Now the ray is traveling from,
Denser to rarer.
so denser to rarer means it will travel in this way. Right. So It goes like this, right? So what is the name of this ray? This is the incident ray. This is the refracted ray, and this will be the emergent ray. Okay. If this is the angle of incidence, then this will be the angle of refraction. I'll call it as R1. If this is R1, okay, how much will this angle be?
R1, sir.
It is still R1, right? And I will call this as E. E stands for angle of emergence. Okay. So at point A, if I apply Snell's law, then 1 into sin I will be equal to mu into sin R1. Okay. Let me call this as equation number 1. At point B, if we apply Snell's law again, then what will happen? Mu into sin R1 is equal to 1 into sin E. This is 2. So from 1 and 2, what is that we can conclude? Mu sin R1 is equal to sin I. So sin I will be equal to mu sin R1 is sin E, will be equal to sin E, which implies angle of incidence is equal to the angle of emergence. So what is that we can conclude? What is an important observation from these angles? Then it says that incident ray, okay, I repeat, the incident ray and the emergent ray are parallel to each other. Okay, incident ray and the emergent ray are parallel to each other. Right? That is what you mean by angle I is equal to angle E. Okay, and you are able to see that this incident ray has got displaced to the left by some value. Okay, then there is a distance delta x here. Any idea of what this delta x is called as?
Lateral displacement, sir.
Correct. So it's called as lateral displacement or lateral shift. It's called a lateral displacement or lateral shift. Very good. Okay. So since it is clear till this step, I hope it's clear, right?
Yes, sir, it's clear.
So since it is clear till this step, what we will do is we will try to derive the expression for lateral shift. Okay. So let me redraw the diagram again. Just a minute. A, R1, R1, and E. Okay. So we need to derive this distance of delta x. So the distance between two parallel lines is always the perpendicular distance. We know this fact, right? Right, this fact is known. If I take the thickness of the glass slab to be T. Then at point A, what does Snell's law tell us? 1 into sine I is equal to mu into sine R1. Correct? But remember, see, tell me one thing. When you do this experiment, right? Let's say you're doing an experiment. Which of these angles will be under your control? What is it you can control? Think of it.
The medium, sir, we are using.
No, I'm asking about the angle, not about the medium. So there are three angles, right? I, R1, and E, right? Out of these three angles, which one do you think is in the hands of the person who's doing the practical or the experiment?
I, sir.
Correct. Why I? Because see, imagine this is a torchlight that you are hitting on the glass slab. You have the feasibility to adjust the angle at which you want the light to hit the surface, right? So based on this only, R1 and E will change, correct? That is not in your hands. So R1 is a parameter which cannot be calculated experimentally. So whenever you are deriving a formula, right, you should have only those parameters that you can control in the experiment. Okay. So sine I will be equal to mu times what is sine R1? That is what we need to know. So if I take this point as P, what is sine R1? What is sine R1, guys? Okay, I'll come to that point. Next. Similarly, if I apply Snell's law at point B, what will we get? If you apply Snell's law at point B, what will you get? Mu into sine R1 is equal to sine E. This is also a known parameter. Now, if I take this triangle, if I take the right angle triangle A, P, and B, what is the distance between B and P? It is delta X. Correct? So,
Yes, sir.
what is okay? If this angle is E, okay, that is one thing. Similarly, oh, I took two pieces. Sorry, this AQB. Similarly, if I take the triangle A, P, and B, what is AP? AP is the thickness of the glass. AP is the thickness of the glass. PB is nothing. AB is also nothing. Okay. Just trying. So delta X. So how much is this angle?
Which angle, sir?
This one. The one I'm marking in red. Just trying to derive the relation.
90 minus R, sir.
should be 90 minus r. That's right. So this angle will be 90 minus r.
Sir, we can use angle theorem, no, sir.
No, I'm not trying to see. I just want to share something, okay? Ideas. Whenever ideas to solve the problems in this case, whenever you want distances, okay, whenever you want the relation between the distances, like how we did for 1 by v plus 1 by u is equal to 1 by f, there are two ways to approach it. One is using the similarities of triangles. So you use similarities when angles are not involved. Okay. And the other way of solving it is using trigonometry, like how I'm trying for this particular problem. So you can use trigonometry to solve.
Okay, sir.
Okay. I'm just stuck with one basic point. I need the angles. That is what I'm looking for. Okay, I'll think about this and get back. Okay. So remind me, we need to find the lateral displacement for a glass slab. Next, what is the other concept that is left out in this chapter? Okay. So this is all about refraction through a plane surface. Okay, I repeat, this is all through the refraction through a plane surface. Now the concept that we are going to see is called as refraction through a spherical surface. Okay. So what I'm trying to say here is, till now we were concentrating on boundaries which were planar in nature, right? Now we'll start concentrating on boundaries which are curved in nature. So let's say there is a curved boundary which is separating media of refractive index mu1 and mu2 on either side. Okay. Here I consider mu1 to be rarer medium and mu2 to be denser medium. Now I'll take a small point object on this axis. So if I take a small point object, we need to complete the ray diagrams for it. So if I take a ray hitting like this is going to be the incident ray, right? So at this point, what will happen? So at this point, we need to draw the normal. So let's say the center of curvature is over here. Then this will be the normal. So this will be the angle of incidence, correct? The ray should have actually traveled like this. But since the ray is traveling from rarer to denser medium, what will happen to it? It will bend towards the normal, means it will travel between the axial path and the normal. So it will start getting bent in this way. This is the refracted ray. Okay. Secondly, if I consider an other incident ray along the axis itself, then it will travel without any deviation, and this will be the point where the image is formed. Is this ray diagram clear? Is this ray diagram clear, guys?
This is like a normal ray diagram, no, sir.
It's a normal ray diagram, but only difference is instead of extended object, we used a point object. Okay, but the difference is, don't get confused when I say spherical surface, it is not a mirror. Okay, it is just a boundary which is in the form of a curvature.
Need
For
not be a
example,
mirror, sir.
it need not be a mirror. I didn't polish it on either side. No, I told that is why I told refraction through a spherical surface. I didn't say reflection. Mirror comes
Okay.
means you will always speak about reflection. Okay, now is it clear?
Yes, sir, it's clear, sir.
Okay. So if I take this as alpha, if I take this as beta, and if I take this as theta, then this will be the angle of refraction. Okay. So as I told you in the beginning of this chapter, the assumptions that we are going to take into consideration are: first, the rays considered are paraxial. Second, since the rays considered are paraxial, angles involved are very, very small. So when the angles involved are very, very small, then angles, sine of the angles can be approximated to the angle itself. Okay. Now, so whenever, remember, one more idea is, whenever refractive index and angles are involved, the only way of solving this, whether it is useful or not, I would suggest everyone to write Snell's law. So if you apply Snell's law at point A, what will you get? Mu1 into sin I is equal to mu2 into sin R. Correct? Mu1 into sin I is equal to mu2 into sin R. So mu1 into I is very small, so it can be approximated to I itself. Sin I can be approximated to I. Similarly, R is very small. Sin R can be approximated to R itself. Let me call this as equation number 1. So please make a note. If there is any doubt, ask me. Okay. Next.
1 minute, sir.
Yeah, writing? Okay.
So I have a doubt, sir.
Tell me.
Is there any difference in the Snell's law here, sir?
Is there any difference?
In the Snell's law formula here compared to the previous one we used?
In which formula you're saying? I didn't understand. In
In
Snell's law.
Snell's law, yes, sir. In
No, no,
Snell's law
no.
at point.
It is the same, right? I applied the same. Refractive index of the medium multiplied with the sine of the angle made by the incident ray with the normal is equal to refractive index of the second medium multiplied with the sine of the angle of refraction in that medium. It's the
Okay,
same
sir.
thing, right? Now, if I take the triangle AOC, if I take the triangle AOC, then here it will be alpha, here it will be beta, and this is I. So what is the relation between all these three angles?
Angle alpha plus angle beta equal to angle I.
Why? Exterior angle is equal to
Sum of
sum of
interior angles.
opposite interior angles. So I is equal to alpha plus beta. I'll call it as equation number 2. Similarly, if I take the triangle ACI, observe, no? If I take the triangle ACI like this, this is R, this theta, this beta. So what will be the relation between all the three? Beta will be equal to R plus theta. So R will be equal to beta minus theta. Let me call this as equation number 3. So what I can do, I can take 2 and 3. I can take 2 comma 3 and substitute in 1. So when I do that, I get mu1 into alpha plus beta is equal to mu2 into R. R is beta minus theta. I hope it's clear. If there is any doubt, please get it clarified. mu1 into alpha plus beta is equal to mu2 into beta minus theta. So we will get mu1 alpha plus mu1 beta is equal to, okay, I'll small it. Mu1 alpha plus mu1 beta is equal to mu2 beta minus mu2 theta. So take this value to the other side, this value to the left. So mu1 alpha plus mu2 theta is equal to mu2 minus mu1 into beta. Okay. Let me call this as equation number 4. Now see, I told that the rays are paraxial. Remember, in this chapter, whenever you say paraxial, this curvature is treated like a straight line. Right? The curvature is treated like a straight line. So if I take this point as P, then tell me what is tan alpha? What is tan alpha?
AC by OC, sir.
AP by OP. So what is AP? AP is a point. So what is OP? It is U, but since this is on the left hand side of the point, generally we consider this point as the origin, right? The point where the mirror and the axis are meeting is generally taken as the origin. So since it is on left hand side, can I write it as minus U?
Yes,
So
sir.
tan alpha is equal to AP by minus U. What about tan beta?
AP by TC, sir. That's AP by V.
AP by
V.
R. R, no?
Yes, sir.
Tan theta is how much? This distance is B. It will be AP divided by B. Right? So, again, if the angles are small, tan alpha can be approximated to alpha, tan beta can be approximated to beta, and tan theta can be approximated to theta. So, where do we have the requirement of this alpha, beta, and theta? The requirement of alpha, beta, and theta are in the fourth equation. So, mu1 into, what is the value of alpha? AP by minus U plus mu2 into, what is theta that you got? I hope you would have written it. It is AP divided by B is equal to mu2 minus mu1 into, what is beta? AP divided by R. AP will get cancelled. So minus mu1 by u plus mu2 by v is equal to mu2 minus mu1 divided by r. So when I write the equation, I'll get mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by capital R. And this is the expression for the refraction at spherical surface. Okay, this one has to be remembered. So please write down. Are you done?
Yes, sir.
Okay. So have 6 more minutes. We will complete this part. Okay. I think we can derive it now. See, if this angle is I, how much is this angle? If this angle is I, then how much is the angle in the blue color? That is also I because
Right,
it is
sir.
vertically
Vertically
opposite
opposite
angle.
angle.
Then this will be how much? I minus R1. So can I say that this angle is I minus R1? Correct. Now, from Snell's law, when you applied Snell's law at point A, what is that you got? You got sine R1 is equal to sine I by mu. Let this be equation number 1. Correct? Now see. Now, from this triangle, what is sine of I minus R1? What is sine of I minus R1? It is delta x divided by t. Sorry, delta x divided by how much? Delta x divided by AB. And from this triangle, what is cos of 90 minus R? Sorry, what is sine of 90 minus R equal to? What is sine of 90 minus R equal to? Or for that matter, R1. So what is sine of 90 minus R1 equal to? Is it not T divided by AB? So which is nothing but cos R1 is T divided by AB. Accepted? Now, what is the unwanted parameter in both? It is AB. Correct? So sine of I minus R1 divided by cos R1, can I write it as delta x divided by T, which implies delta x is equal to T into sine of I minus R1 divided by cos R1. Accepted, guys? Is there any doubt?
1 minute, could you show the diagram?
Yeah.
Done, sir.
Okay. So T into what is sine of A minus B? Sin A cos B minus cos A sin B, the whole divided by cos R1. So T into sin I, can I relieve it as sin I minus, this can be written as cos I into tan R1, right? So T into sin I minus cos I into, what is the value of tan R1, guys? We got sin R1 is equal to sin I by mu. So if I take a right angle triangle where it shows R1, this is sin I, this is mu, then how much will this be? Root of mu square minus sin square I from the Pythagoras theorem. So cos I into, tell me what is tan R1 from this triangle? It will be sin I divided by root of mu square minus sin square I. So what can be taken out from the numerator? It will be T sin I into 1 minus cos I divided by root of mu square minus sin square. Okay. So I told you, right? The lateral displacement is measured in terms of T stands for what? It stands for the thickness of glass slab. I stands for the angle of incidence and mu stands for the refractive index. All these parameters are in your hand. So when you do the experiment, you have the possibility to control all these parameters. So delta X can be found through an experimental analysis. The reason why someone tell me why I didn't take this as the formula? Why didn't I take this as the formula? I could have stopped with that. No, why did I do all these steps? Can you guess? It's very simple, man. Look at that, you will get the answer. What did I say? From the beginning, I'm telling.
Refractive index is
No, refractive index, not a refractive index is missing. Look at the parameters which are under your control. Thickness of the glass slab, you are allowed to choose whatever thickness you want. Angle of incidence you can control, but angle of refraction you cannot calculate it through the experiment. How will you calculate some angle which is happening inside the prism? You can't do it, right? Or inside the glass slab, you can't do that. So that is the reason why we had to proceed with all these steps and come to this value. So this is the formula, that is T sin I into 1 minus cos I divided by root of mu square minus sin square I. Just to
So, sir, we'll be
understand,
using this formula in questions, sir.
yeah, you have to use this. Okay. So if you see, I'll show you a question. There is a ray of light which is incident at an angle. So I is given. On the face of a rectangular glass slab of thickness T is given and refractive index 1.5. Calculate the lateral shift produced. Will you be able to use this formula now? So T is there, I is there, refractive index is there. Will you be able to use this formula and find the answer here?
Yes, sir.
Now you're able to understand. So this is how we need to derive the formula. Okay. So that's all from my side for today. Next class, we will discuss some more problems and then we'll go to the next concept.
Yes,
Okay.
sir.
So I'll see you then.
Thank you, sir.
Thank you, sir.
Thank you, sir.